Alrighty. Okay. Hey everybody, my name is Ben. I'm going to be talking to you guys today about building modular Angular apps and scaling them as your business grows, as your application grows in complexity, how we think about that problem, and what tools we can bring to the table to try to solve it. So, in lieu of boring you with a bunch of personal details about myself, I'm going to direct you to Twitter, which is the easiest way to find out about me and contact me. And then I'm going to use the time that I would have spent telling you lots of things about me that you don't really care about to tell you something that I want you guys to do during this presentation to interact with me. And that's these usernames and avatars. Right now that's me, but you're going to see other people down there during the presentation. I think one of the amazing things about working on modular open source technology is that it's not big companies. It's just individual people who pour blood, sweat, and tears into some pretty amazing software. They really care about the end user developer experience, and they're volunteers. So I want you to follow them on Twitter, follow them on GitHub. These are really smart people, and you can learn a lot from them. But if you're willing to, I would also love for you to tweet at them, include me in that if you'd like, and let them know that the Angular community is large, it's passionate, and that we appreciate the work that they're doing, because they will appreciate that sentiment. So we're going to divide our conversation into 3 pieces today. Number 1, why do you need a module loader? Number 2, I'm going to introduce Browserify, a module loader that I happen to like. And number 3, we're going to talk about why small composable modules are incredibly important to JS and why I think it represents the future of how we're going to build applications. So number 1, why even bother? Why do we need a module loader? And to answer that question, I think we first need to understand what the majority of us are doing right now, and then we need to understand what's out there and what we can gain. So I just want to do a quick poll by a show of hands. How many people, when you go to bootstrap a new Angular application, when you're getting started on a new project, you go to angularjs.org and you click the download button and you drag and drop the script from your downloads folder into a project folder? Okay. A hand here or there, and that's fine. How many people Bauer install Angular? Okay, that's a lot. And that's why we start by talking about Bauer here, because that's what the majority of the people are using. And Bauer was actually created for tools like Angular. And so we're going to look at what Bauer does and what Bauer doesn't do, and try to bridge the gap for what we want. So Bauer is a package manager for the client side. That's an important distinction because it's not a JavaScript package manager. You could throw CSS in Bauer. You could throw fonts. Bauer is just for everything client side. It downloads packages from a Git repo, so it doesn't have a registry for code. It just interacts with something like GitHub. It handles semantic versioning, which is a complicated term for something that you've all seen before, and we'll go over that quickly. And it'll download dependencies for you. So just a quick primer on semantic versioning. I say I want Angular at a tilde, which is a semantic version operator, 1.3.13. Bauer says, here's Angular at 1.3.16. All that's doing is saying, we want all the patch versions. That's what the tilde means. And Bauer will automatically give us a newer version that satisfies the range that we asked for. And so that's a definite step up over downloading things directly from angularjs.org, because we basically get automatic bug fixes every time we go to build, and we don't have to manually go and update. So that's definitely a win. But then we get into the other feature, dependencies. And this is where things get quite a bit trickier. And so Bauer will handle dependencies for us, so our packages can say that they have dependencies of their own. And then you get into the classic Bauer problem, and that's that there's really only one mode in Bauer, and it's vomit all problems onto the user, onto the developer. And so if you've ever used Bauer before, you're familiar with this sort of output here. It's very verbose, it's very confusing, and in some cases it may be somewhat helpful. So let's take the case of we have Angular 1.3 and 1.4 side by side. That clearly makes no sense. But underscore, that's actually not the case here. So we definitely don't want to be including 2 fat copies of underscore in our final production build. But in the short term, just for building our application, there's actually no reason why we can't have 2 versions. So this is an issue where Bauer is kind of giving us a problem with no clear answer and making us think that we can solve it. And so for one that's a pretty terrible user experience, we don't know what to do about that. But for 2, it violates a core concept that we're going to be talking about today, and that's that we build our applications around a dependency graph. And what a dependency graph looks like is basically just your application code at the top level, A, B, and C, a couple of dependencies, and that's something that Bauer handles okay. Let's say A is Angular, easy enough. But then a true dependency tree, you start getting into deeper levels of dependencies, where the packages that you're depending on have packages that they themselves depend on for various utility functions. That's how we build big applications, and Bauer really doesn't know how to deal with that appropriately. Because what it gives us in response to that situation is just a flat list of dependencies in a single folder. And so this violates a core principle of application design in any system. And that principle is that the secret to building big things is actually just not building them at all. Build small things instead. This is Adios Mani at Google. And this is something that we should be proud of, that we can take a really complex problem and break it into small pieces. What we should not be proud of is how many source lines of code there are in our application. It shouldn't be a badge of pride to have a 200,000 line application that's enormously complex. That's a liability, and we want to avoid that by building smaller pieces. And so with that in mind, our goal is smaller pieces. We sort of see a trade-off around Bauer. And that trade-off is that it's better for large or misbehaved modules, and we'll define this in a second. But it's dramatically worse for small and well-written modules that follow the philosophy that we're talking about here. And so large modules are things like Angular or jQuery, where it either makes no sense at all to include 2 of them, or it's completely impossible. It just breaks. Misbehaved, you could probably level that term at Angular. So if you've ever looked at the Angular source code, it can be incredibly difficult to contribute to because you'll find all of these functions littered all over the place, utility functions everywhere from uppercasing strings to doing more complicated things. And because Angular is concatenated, a bunch of files are just glued together in order to build the actual AngularJS script that you get at the end of the day, it can be incredibly difficult to figure out what's going on there. So Angular has a big fat build process around the way that it's structured its application, but for other people who want to be more explicit and make sure everything explicitly ties to a bit of JS, Bauer makes it really hard, because at the end of the day, we're just going to have everything in one big folder and then have to hook it back up together. So at the end of the day, we just go the Angular route all over again, and we inline all of our functions, and then we concatenate, and then it's impossible to understand our code. Small, well-written modules, let's define that as well. If you want an example of small and well-written sort of as a philosophy, you can look in the majority of the computers that we have out here, and that's Unix. Unix has stood the test of time because we have very small units of functionality, things like grep that do one thing and they do one thing well. And then we have operators for piping these different programs together. And so we can understand our code or our running program one piece at a time. And that's how we want to think about JavaScript. We want to think about individual units of understandable functionality that we glue together and only turn to big things like Angular to solve the especially hard problems that may not just be one little library. And let's cover briefly a second issue around Bauer. And that's script tags, and that's basically what it leaves you to do once you've installed your dependencies. So you have to go into your HTML document, add a script tag pointing to like your Bauer components folder for every single dependency you've installed. When that changes, you have to go put a new one in there. You have to make sure the order is right so that Angular comes before Angular modules. And of course, most people don't do literally that, but what they do is effectively the same, because concatenating your files is really just the same organization structure as script tags, where you have to manually tell the computer how all of your scripts fit together. Yes, it doesn't have 20 HTTP requests the way that actual script tags would, but you're still forced to do all of this work that the machine can do for you. And so let's sum this up. Why do we need a module loader? We want to build our applications without manually specifying every script in order, and this is going to be more and more important the larger our applications get. So this is no big deal for a quick prototype, but as we develop a huge application with thousands of files, we can't be forced to order those manually. We want the machine to do the work. We want dependencies without conflict vomit, so we can have Unix-style development of single-role packages, and we don't really have to know what goes on under the hood. And lastly, there are 158,902 packages on NPM. This number is surely already out of date. And it would be really great to use them. NPM is an amazing ecosystem that we're going to cover a little bit later. And so that's something that we would love to do in order to fulfill that goal of having Unix-style development in JavaScript. And so that brings us to a tool called Browserify, created by James Halliday from Oakland, Substack. He is a very prolific JavaScript programmer. If you're looking for someone incredibly smart to follow, I highly recommend him. And so Browserify does something relatively simple through a lot of complicated steps, and that's basically just understanding how the require algorithm from Node.js works, traversing it recursively, so finding that you required a particular file and then going and hunting in that file for more requires. It finds all of your scripts, it puts them into a bundle in order. It's a single file that can run in the browser. And so we've basically allowed our source code to do what we had to do before with script tags. Only one source of truth, no opportunity to create bugs. And so let's look at this in Angular. Shout out to Pete Bacon-Darwin, the Angular 1X lead, who sat with me on Google Hangouts one morning to make sure that this got shipped in Angular 1.3.14, so it's quite new. So we can require Angular. That's pretty straightforward. We create a module. This is no different than you would do normally. But then where things get a little bit unusual is this array, where we're adding require statements inside of the array. And inside that array, we expect to have strings that represent module names. And so if we actually look at the source code for Angular resource, this is why this works. We're requiring the original Angular resource script. This is what you'd get from Bauer. And then we're exporting a string. And so if we go back and take a quick look, what you realize is happening in one single function call in that one require Angular resource is the registration of the module and the presentation of the string with no duplication. So this is a consistent theme. How can we avoid duplicating build steps? Because those are a recipe for bugs and for frustration. So in this case, we have no duplication whatsoever. As long as Angular resource is installed, this application just works. Building is this simple. You can get quite a bit more complicated if you'd like around things like breaking your bundle up into different files, app and vendor. But out of the box, Browserify can do something this easy where you tell it, here's the entry point, and you pipe the output to a file on disk. This is a CLI running in Node. It's simple Unix, and you can do it in one line. And so with that, we've achieved building our applications without manually specifying all of our scripts in order, and that's making us more productive, and it's making our applications less error-prone. You can also grab Angular off of NPM, so you can install Angular, save it to your package JSON. You can install Angular mocks also from NPM, as well as all the other packages in the Angular ecosystem, things like resource and cookies. And so let's talk about NPM real quick and why this is so important. So NPM is the node package manager, but we're trying to run as far from that name as possible as a JS community, because NPM is no longer the node package manager. It's really the JavaScript package manager. And so let's look at that statement and try to understand it. So this is PyPy and Ruby Gems, two fairly mature package managers for popular languages for reference. This is going a couple years back, and so Bauer is relatively new, but it's definitely growing. Except then you put NPM on this graph, and it's just a whole different story. NPM has grown fast from day one. It's growing incredibly fast today. And it's an ecosystem that's a bit different than Bauer. It's an ecosystem of packages for doing everything from manipulating data to manipulating the DOM. You can put anything in NPM, and more importantly, NPM makes it really easy for you to install nested dependencies. So we have access to 150,000 plus packages on NPM, and it's easy. And those packages are nested. So here's an example of a node modules folder with a module that I wrote in there called Angular Credit Cards. Angular Credit Cards is actually just a super lightweight set of directive bindings on top of credit cards, which actually does all of the business logic work. Underneath there is a simple module for camel casing, a module for type-specific work on credit cards, and a module for the LUN algorithm. All of this stuff is done for you automatically when you npm install Angular Credit Cards. The rest of the structure is created automatically. But if there were a conflict, let's say with camel case, that's like a 100-byte module. And so if someone else wants a different version, they'll just get a different version, and your applications just work. So that's dependencies without conflict vomit. And lastly, I want to talk a little bit about why this really matters. I don't think this is just another build tool. I think this is more of a philosophy about how we build applications and a toolkit that happens to work well today. It's not about Browserify. It's about the methodology. And so I want to propose a somewhat unusual goal for people. And that goal is to use less Angular in your applications. And so let's talk about what I mean by that, because I don't mean stop using Angular. So here's an example, testing without dependency injection. So I think it's sort of standard dogma that Angular is really great for testing. And sometimes that's true, sometimes it's not. Dependency injection can be extremely cumbersome because you have a global registry of all of your modules and services. And so if somebody happens to use the same name as you for a service, everything breaks unexpectedly. Require, on the other hand, node style, is entirely local. So there's no concept of a global name for a particular module. Everything is explicit. And you can do the same sort of dependency mocking that you might with Angular with a great package from a friend of mine, Thorsten Lorenz, where you can proxy require and easily stub dependencies in your tests. And you may find that this helps you be more productive around testing than trying to do everything through the dependency injector. I think an even more important example is directives. Directives are hard. We all know this. And they're a huge part of Angular. And so in a lot of cases, when you have a hard problem to solve, the answer used to be you just need to understand the directive API better. And what I'm going to propose instead is that we solve it with magic. And that magic is something called functional UI rendering. This is a concept that was popularized by React, but we're going to take it outside of React. So this is a pretty simple function for creating a user profile, like a little card with me and my friends. It's an ES6 template tag with some interpolation. And we're going to put my name up there, and then we're going to create an unordered list, and we're going to iterate through all my friends and put LIs in there. So the dream in front-end programming is that we could just do this, and then every time our data changes, we could just call this, blow away the DOM and put the new result in there. Because that would be incredibly easy to reason about. It would be incredibly easy to understand because there's no magic. There's no state to manage. It's just variables go in, template comes out, it's deterministic, and that's what we want out of our code. Of course, you can't actually do this in the real world for an application because the DOM is really slow. And so if we just took our whole application, tore it down every time, and then built it back up from all of these little template partials that we functionally rendered, it would be a huge mess. Nothing would run. And so instead, we turned to something called virtual DOM. And this was created at Uber by Matt Esch, among others. This concept was pioneered by React, but you don't have to use React to take advantage of it. You can use virtual DOM alone, or you can use virtual DOM in the form of a package called base element from Kyle Robinson Young that gives you sort of a component-style wrapper that's a little bit nicer than using virtual DOM standalone. And what I think is so important about base element, if you look it up on GitHub, is at the very top of the README is here's how you use base element with Angular, here's how you use base element with Ember, here's how you use base element with React, with web components, and the list could go on. The goal here is writing code that works everywhere and that uses this single, incredibly powerful abstraction to solve our problems. And it is the easy way out, but I want you to appreciate that that is the easy way out. We want to write JavaScript code that's easy to understand. There's no bonus points for using every single feature of Angular. There's no scorecard. We want to write the best code, and if Angular is that way, then let's go with Angular. If we're writing an incredibly complex directive and functional rendering is an easier way to do that, let's go with functional rendering because React is 150 kilobytes, but virtual DOM is a few kilobytes, and we can include it in our applications without having to spend 2 months learning another enormous API. And so that means we don't want to couple our code to a large framework if we can avoid it. So we want to use the bits of Angular that make us most productive, but there are no bonus points for using all of it. So if dependency injection is tripping you up in a particular place, just don't use it. Go use CommonJS and use ProxyQuire to do your testing. Coupling your code to a large framework means that things like the Angular 1 to 2 transition are way harder for you. If you wrote generic JavaScript and then did your little bit of UI work on top of it, coupled to your framework, it's a lot easier to build multiple applications, potentially in different frameworks, and just to evolve as the ecosystem grows. Change is really the only constant in JavaScript, and so we want to expect it, and we want to build code that is resistant and, if anything, embraces change. So as the ecosystem grows, our code can evolve as needed. We're never going to have something that lasts forever. We're going to have more powerful computers and more powerful devices, but we do want to write code that can take advantage of that in small increments. So we want to do that component by component or module by module, not rewrite our application every single time there's a new innovation. And the last goal here is to publish open source packages to NPM. NPM, as we covered, is an amazing package manager. There's an amazing wealth of packages there that do pretty much everything you could possibly think of. And publishing open source packages there is probably the best way to grow as a developer. At least that's what I believe based on my own experience. Publishing open source things, it's hard to start. Once you do, it's incredibly rewarding, and it's an open marketplace for ideas. So I want fewer people who call themselves Angular developers, or who call themselves React developers, or who call themselves Ember developers, and more people who just write JavaScript, and they do it open source, and so we can learn from each other. We can have good ideas, we can have bad ideas, and when we have the bad ideas, they're well contained in their own packages, and so they can die independently without dragging us all down. But this is incredibly important for JavaScript. if we're going to come together as a community and start to build things that actually work, as opposed to bickering over whose framework is best, which isn't really helpful for anybody. And so that's it. I want to thank you guys for having me today. These are all the places that you can find me, especially NPM. You can catch up with what I've been working on most recently. And the one thing I really do want you to take away, though, is that this stuff is incredibly easy, that you can do it incrementally, so you can try it in a very small way. And this is something that you should take away and go try instantly, because I guarantee you there's at least one problem in your application that something on NPM will solve in a meaningful way. Thank you.